So in this video, we're going to be learning about rearranging equations with variables. This is not new stuff for sure. You've been rearranging equations for years. Sometimes people feel a little bit less comfortable rearranging equations with variables than they do with numbers. So that's why I thought we'd go over this. So why do you have to use variables? Why can't you just plug in numbers right away? Well, it turns out in physics that a lot of equations or a lot of problems are actually unsolvable when you plug numbers in right away. You'll run into situations where maybe you don't know the maths and it looks like if you're constrained to plugging in numbers, you would just be stuck. You couldn't even do a single step forward. But if you keep going, just using the variables and rearrange your equations that way, it'll turn out that math cancels and you didn't even need to know it in the end, which is it's a really exciting moment when that happens. And you'll be able to just solve so many more physics problems if you can rearrange equations with variables than if you're sort of constrained to plugging in numbers in. That really holds you back if you've got to plug numbers in. The next reason is just rounding errors, which are annoying. Either you have to write down a gazillion decimal places to avoid rounding errors, or you are stuck with them. We just want to avoid that altogether, and we can avoid that just by rearranging equations with variables. The next reason is just communicating your solution well. If you want to explain your work to someone else, it's a lot easier to do if you can show them how the variables move about than if you're trying to show them how the numbers move around and those numbers change as you go and it gets really messy. So using variables just makes your solution so much more beautiful. The last reason is sort of an intuition check. So when you get to your final answer, if your final answer is just a number and there's no sort of equation before that number, it's really hard to verify, does this make sense in the real world? Does this fit my understanding of the world? Whereas if your answer is actually an equation that shows how variables are working together, you'll be able to see, does my answer make sense? And your answer will also feed your own intuition of the world and help you understand how physics and the real world are connected a little bit more. This course is all about bridging that gap between sort of an abstract world of physics and the real physical world that you interact with every day. And rearranging equations with variables is actually one little step in bridging that gap. So we're going to do this with just a few practice equations, starting with easy ones, building up to harder ones. When I rearrange equations, I like to use a tool that I would call backwards bedmass. You actually don't have to do it this way. There are actually many ways to rearrange equations. But I find the easiest way to do it, where you make the fewest mistakes, is by thinking about backwards bedmass. So bedmass you're really familiar with, that's your order of operations. When you're plugging numbers into an equation, you plug in the brackets first, and then you solve for the exponents, and then you do division and multiplication, and then you end with addition and subtraction. So that's to solve an equation, that's your order of operations. But to rearrange an equation, it can actually be handy to think about bedmass backwardsly. So start by dealing with your subtraction first, then deal with your addition, or you can deal with those at the same time, then deal with multiplication and division, then deal with exponents and deal with brackets last. That tends to be the easiest way to rearrange an equation. So I'll show you what that looks like. Here, we're trying to rearrange for acceleration, right? So I could either move the v1 away from acceleration or the delta t. It's going to be a lot easier if I move the added thing first. So I'm going to move the v1 first. v1 is being added, there's a little hidden positive sign in front of it, so I'm going to subtract it from the other side to move it away. So I'll have v2 minus v1 is a delta t. The delta t here is being multiplied, so now I'm moving from the adding subtracting part of my backwards bedmass to the division multiply. So to get rid of delta t, it's being multiplied. I want to do the opposite. I'll divide both sides by delta t. Make sure you divide the entire side by delta t there. That cancels out my delta t, and I have acceleration on its own. I'm actually done at this stage, but the last step I like to do is just write it forward. So I like to put the variable I'm solving for on the left. It just looks nice. v2 minus v1 over here over delta t. And we're all done. My next equation here, v is delta d over delta t. I'm trying to rearrange this for time, and time is on the bottom. The delta t is on the bottom here. As soon as you're solving an equation for a variable in the denominator of a fraction, you want to get it off the bottom as quickly as possible, because it's going to mess you up if you leave it on the bottom too long. So if you can get it off the bottom in the first step, do it. And here you can. How would I get delta t off the bottom? I would just multiply both sides by delta t. So I'll multiply this side by delta t. That kaboom kills it off the bottom. Then I have to multiply this side by delta t, of course, as well. And I'll just rewrite what I've got here. I have delta t times v is delta d. And now I'm actually almost done. I want delta t on its own. V is being multiplied by delta t. So I'm just going to divide both sides by v. Kaboom! Kills my v over here. And I've got delta t on its own is delta d over v. And we're done. By the way, with this equation, there's actually a nice trick you've probably seen before, and I just wanted to review it for you because it's just handy. It'll speed your life up a little bit. So if you write out these triangular equations like this, so V is delta D divided by delta T. So this is like a triangular shaped equation. You can put it in a triangle. Go like this. Take your fraction bar and carry it through just above the equal sign. Take a line and draw it down through the equal sign, like that. And now you have this beautiful triangle that kind of lets you rearrange for any variable in that equation really fast. So we have our first rearranging is V is delta D, see how it's on top, over delta T, see how it's on the bottom. But then delta T over here is going to be delta D, see how he's on top over there? And then he's over top of V, so V will be on the bottom. And then delta T over here, delta D, sorry, did I say T? Delta D, the guy on top here. He's going to be V times delta T. Those are right beside each other, so V times delta T. So that's just rearranging for each equation in that little triangle without having to do any math. So it kind of looks magical, and it is. There's no math involved in that. It's just a quick trick that can skip a step for you and let you do that rearranging a little bit faster. So you're welcome to rearrange these equations either way. This will be the sort of true mathy way. This is kind of a cheating trick, but you do this so often in a day that this can just speed up your life a little bit there. All right. Here's one that looks really long, but it's actually not bad at all if you just go through your sort of backwards bed mass, one step at a time, you'll be fine. Here I'm trying to rearrange for acceleration, and the first thing I'm going to look at is, well, what's being added and subtracted here? So I want to get rid of any terms that are added and subtracted to the acceleration term. So here's my acceleration term, the v1 delta t, that's being added, so I'm going to move him over to the other side, I'll subtract him. The d2, he's being added, so I'll subtract him from the other side too. In fact, why don't we do both of those in one move? So d2 stays put, d1, he's going to be subtracted on this side, and v1 delta t, it has to move all at once, right? So the whole term moves over, it's going to be subtracted, v1 delta t. That gives me 1/2 a delta t squared over here. All right, next I want to deal with multiplying and dividing. Well, the 2 is being divided here, right? 1/2 is a dividing by 2. So I could deal with the 2 by multiplying both sides by 2. That would kill the 2 there, kaboom, he's off the bottom. I have to multiply this side by 2. What I wrote right now, though, is wrong, right? I have to multiply the entire side by 2. So when you do that, you've got to put this in brackets so that you're multiplying everything on that side by 2. Really important. I'm actually almost done. See how all I have left on this side is a delta t squared? I can just divide both sides by that delta t squared, and that kills the delta t squared. It's all gone there. I'll divide this entire side by delta t squared, and I'm all done. I have one lovely equation for a. I'll just write it out nicer because it looks messy there. So a is 2 times d2 minus d1 minus v1 delta t, and on the bottom, delta t squared. I'm all done. I've got my equation rearranged for a. Just a thing to think about, what if you were taking the same equation, d2 is d1 plus v1 delta t plus 1/2 a delta t squared. What if you're trying to rearrange for delta t? Because there's a delta t over here and here. So it seems like, well, how would can't move things away from delta t, there's delta t in 2 places. This is actually a quadratic. So if you're trying to solve for delta t, and it's clearly a quadratic, you've got the squared here, the single term there, the constant there, you can use the quadratic equation. If you remember that from grade 10, I really hope you do. It's a bit trickier using the quadratic equation with these, so we're going to practice this a lot in class when we get to this this kind of problem. It'll be in a couple weeks, not right away at the beginning. But just to give you a heads up sort of for how it will work, is you're going to rewrite it as a quadratic. So I would put the squared term first, so that's my 1/2 a delta t squared, that one goes first. Then the single delta t term, so it's the v1 delta t, and then the constant at the end, so that's the d1, and actually part of that constant is the d2. I have to move it to the other side, so he's being added here, so I'll subtract him on this side, minus the d2. And now that I've gotten rid of d2 over here, I just have a 0 over there. So that's actually a really nice quadratic, and often you know how we think about quadratics as like ax squared plus bx plus c. Well, the a is this right here, the b is what's in front of the delta t, and the c is the entire constant at the end there. Then you can actually just plug this all into your quadratic formula. which is delta t equals, there's a little song if you know it, negative b plus or minus the square root of b squared minus 4ac all over 2a. There we go, and you'll have delta t. We're going to practice that lots, so don't worry too much there, but just a heads up for you can solve things that are even trickier. Even when you have like a delta t and delta t squared, you can still solve for any variable that you want. All right. Here's actually an easier one, not too bad. We're just trying to solve for the d squared on the bottom. Thought I'd show you this one just as a way to use both your cool triangle as well as the regular sort of mathy way. First thing is, don't be scared of this g sitting out front here. That's a constant. Often we write constants in that sort of format, but it just means it's part of the top of the fraction. So you could rewrite this and it would mean exactly the same thing to rewrite it like this. The g is on top, the m1, the m2, and the d squared. And if I wanted to solve this in the sort of traditional mathy way, what I would do is immediately get that d squared off the bottom. Right? I'm trying to rearrange for a variable on the bottom. Don't like that. So I would multiply both sides by d squared. Get a d squared over here. That kills the d squared on the bottom, which is good. And then I would just need to, I'll just rewrite that out. So d squared, force of gravity, g, mass 1, mass 2. I would just get rid of the force of gravity here by dividing both sides by that force of gravity. That gives me d squared on its own. And my last step is going to be to deal with that squared business. So to deal with a squared, I just have to square root both sides. Square root this side. That squared cancels the square root there, and I get d on its own is going to be the square root of g mass 1 mass 2 over the force of gravity. Just to show you what this would look like with your triangle, so you could write it like this. Force of gravity is g, it's on the top, just write them up with the masses here, divided by d squared. And put this all inside that cool triangle we talked about. Draw that fraction bar extended over the equal sign, draw your line down through the equal sign. And then d squared, so that's the variable in the bottom here, is going to be everything on top, g mass 1 mass 2, divided by your force of gravity right here. And then my last step would just be to deal with the squared, square root both sides, that cancels the squared. So you can see how that's a little bit faster if you use your triangle. Both ways are completely legit. Do whichever one you feel more comfortable with. Here's another one with a squared business to worry about. I just wanted to show you it because sometimes people cancel too many squareds and square roots, so I just wanted to make sure you're aware of this. So here I'm trying to rearrange for v1. I'll deal with adding and subtracting first. This entire term here is being added, so we're going to subtract him from the other side. So I'll get v2 squared minus that whole term, 2a d2 minus d1, and I don't even have to go inside that bracket because I'm not trying to get out d2 or d1, they're all good in there. And I get v1 squared over here. So all I have to do next is just deal with the squared, jump right to dealing with exponents in my backwards BEDMAS strategy. Square root to get rid of the squared, and I'll have to square root this entire side, like that. This is where I see some mistakes and it makes me sad. This square root cannot cancel that squared. So the square root can cancel the squared here because all that's inside that square root is just a single variable. If it was a variable multiplied by something else, you could still do that cancellation if it's a multiplication or division inside here. But if there's adding or subtracting under your square root, you cannot touch anything. You can't cancel that square root and that square. Don't even do that at all. It would make me sad. So you're just done at this stage. Don't try and simplify that further. I would just write it out a little bit nicer, put the v1 on the left, and we're good to go. So this is a case where I see people make mistakes just by doing too much work. So don't go further. Don't try and cancel your square and square root there. If there's adding and subtracting, you can't touch it. You're done. All right, the very last one. This kind is a little bit trickier, but maybe I call it an extra challenge for this current stage in our course, but by the end of our course, you'll be doing these with your eyes closed. You'll be awesome at them. Okay, so here I have two equations, and I don't know the acceleration. I'm trying to solve for the initial velocity, so that's v1. but I don't know what the acceleration is. So if I just rearrange the second equation, I don't have enough information. I could start there, right? If I want to get v1 on its own, I would just move the a delta t term to the other side. So I'll do that. The v2 minus the a delta t term will give me the v1. So I've got v1 on its own, but the problem is I don't know the acceleration, so it seems like I'm stuck. So if you are the kind of person that plugs numbers in right away, you will be stuck at this point because you don't have acceleration, you can't go anywhere. This is where it's really handy to be able to rearrange with variables. We're going to take the first equation here and try and solve it for a. So I have this sum of the forces, that's what that means, is mass times acceleration. I'm going to rearrange this so I have just a little equation for acceleration here. So I'll divide both sides by mass, and I get acceleration on its own. Acceleration is the net force over the mass. This equation here, I can then actually sneak in for the acceleration right there and just boom, kick out acceleration, replace it with what it is, which is net force over mass, and then I don't need to know acceleration anymore. So let's write that out. I would have v2 minus, instead of the acceleration, I'm going to write net force over mass times delta t is v1. And there you go. I've got an equation for v1 that doesn't rely on acceleration. I could just write it forward so it looks nice. And you're all done.